Alright, welcome back from Mardi Gras break. Let's do another edition of Crush Lustre Television, boys and girls. Check it out. Today we're doing Axis of Symmetry. Axis of Symmetry. This is really important when we talk about parabolas, which is what we've been talking about the past couple of lessons. Let's check it out in a business context right here. Read along with me. A company's yearly profits from 96 to 2006 can be modeled by the function y equals x squared minus 8x plus 80. Okay, so I'm looking at that, and I know that the parabola it's a parabola because I see x squared, I see the quadratic there, and also it is going up. So I'm thinking it looks like that. So the profit went down, 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 down in this company, then it went back up. That's what it's saying to me from 96 to 2006. I already know that because I know stuff about parabolas from the last lessons, where y is the profit in thousands of dollars. Okay, y is profit, and x is the number of years since 96. Okay, what was the company's least yearly profit? Least. So that would be whoop down there on the parabola during the time period. Okay, so we did that before. Let's check it out. So what we did, if you remember, is we found the two zeros, and then the vertex was right between them, and then we just plugged it in, if you remember that. Unfortunately, watch this. Let's try and factor this thing right here, shall we? So I got negative 8 on the top and 80 on the bottom. Can you factor that? No. You cannot factor that easily, can you? Because you have a positive right here, and I can't think of anything that adds to negative 8. Okay. So here is another way to do it. We find the axis of symmetry. Well, what the hell is the axis of symmetry? Axis of symmetry is if you have a parabola, like so, what cuts it in half and goes right through that vertex, this imaginary line, see how it's dotted like that? That is called an axis of symmetry. Write that in your notes. This axis of symmetry like that. Because it is breaking the parabola into two equal parts on the left and the right. Okay, so that's the axis of symmetry. It's an imaginary line. So if I can find this line, what this is, and I can plug it in, check this out. So here is the formula. X equals negative b over 2a. Well, what the hell is that? Well, when you look at this, y equals x squared minus 8x plus 80. A is right in front of the x squared. That's 1. B equals negative 8. Sorry, with the equal sign. And C equals 80, like that. So what I do is, so I'm plug in B here. So write this down with me. X equals, you should have written this down too. Everything I write, you write, right? So we got negative, and b here is negative 8, so it's negative 8. Negative 1 times negative 8 over 2 times, what's a? Oh yeah, 1, like that. So what is that telling me? Okay, so negative, so negative times negative is positive, and 2 times 1 is 2. So x equals 4. So that's where the parabola reaches its lowest point. And x stands for years since 96. So 4 years since 96, that's 2000. It looks like we have the least. So I want the profit, so I want the y. So if I know the x is 4, what am I going to do? Oh yeah, I'm going to plug it in to the original y equals 4 squared minus 8 times 4 plus 40 equals 4 times 4 is 16 minus 32 plus 40, and I have negative 16 plus 40. Sorry, 80. I don't know why I'm putting in 40. It's 80. My bad. 80. And so that would be 64. 64 is y in thousands of dollars, so it's 64,000. There you go. So without factoring, I was able to get the vertex. So the vertex is at 4 and 64. So 4 and 64 up here. Here's the vertex. So it's right up there. So if I was to do that, the answer is whoop, C. All right, we got it. There's your real life context. Ooh, try this one now. A company's yearly profit from 2000 to 2015 can be modeled by the function y equals x squared minus 6x plus 40. That's probably where I was thinking about the 40 from the previous problem, why I didn't put 80. So where y is the profit in thousands of dollars and x is the number of years. Okay, try this one. Pause the video. See if you can find the least yearly profit. I'm going to do it in a second. Ready, set, go. All right, welcome back. All right, let's see what we got. So first you have to find the axis of symmetry, negative b over 2a. So in finding x, how many years since 2000 is my minimum or my vertex right there, my least yearly profit. Okay, so that would be negative 6. So negative 1 times negative 6 over 2 times a. What was a? Oh yeah, 1. So that's 6 over 2, which is 3. So 3 years after 2000 is where we hit the least profit. Okay, what I'm going to do, I'm going to plug it back in. So I have 3 squared minus 6 times 3 plus 40. I think I have that right this time. So it's 9 minus 18 plus 40. Writing this down, checking your answer. Negative 9 plus 40, and you have 31. $31,000 was the least yearly profit. 3 years after 2000, so in 2003. Got it. Hopefully you got that with me. Now let's put it in a more general context. Check this out. Excuse me, flip the page. Vocab. Okay. So I'm going to try and do all this, and you're trying to do the one on the bottom. So I'm going to do A, you're going to do B. Check it out. All right, standard form of a quadratic function is, well, that's y equals all this. A, x squared. A goes in front of the x squared. We already got that. B goes in front of the x, and then C is the constant there at the end. Got it. The shape of a quadratic equation, the shape of this thing is a parabola. So we got this, crossing it out as we go. Okay, number 3 is pointing to this dotted line where it breaks the parabola up into equal parts. That is our axis of symmetry. And now you can see it for real. Right there. Now you can see it. Blah, 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 blah. That's what we were finding on the last page to find the vertex, which is, number 4, where that is pointing to. That is the vertex. Okay, 5. When the vertex is at its highest point on the graph, we call that so the vertex at its highest point, like that, when it is flipped, that's called a maximum. Got it. When the vertex at its lowest point, we already did that last page, that is its minimum. Okay. Our solutions are the... what do we have? X-intercepts, solutions of the x-intercepts. We solved those right there before. And solutions of the quadratic equation are called roots or zeros. The last 2 answers are sort of interchangeable. You can do them either way. Okay? So you got all the vocab, we got all the words, yeah, cross them out if you want. If that helps you, boom, here you go. So try and do this one. Ready, set, pause. Alright, it was the same thing. Hopefully you got that. If you didn't, raise your hand. Here we go. So now, we're going to look at some parabolas and see if we can get it. So I'm going to do 1, you're going to do 2. I do 1, you do 1. Let's check it out. First, axis of symmetry. What is that? Oh, I have to draw that. The imaginary line. Do this on your paper. Okay, so that line is x equals, because it touches the x-axis, right? X equals between 2 and 4, that would be 3. Got it. Vertex, so that is here, vertex, so it's 3 and negative 2. That's the least point, vertex. How many zeros do we got? Zeros, that's where it touches the x-axis right here and here with an orange, crush orange. So we have 2, and 1 is 2, 0. That's 1 point. Don't just write 2. You can't do that. You got to say the extra point, and then 4, 0. Boom, got it. Domain. Domain stands for the x values. Write that down on the side. And range stands for the y values. You should have already seen and heard those before in previous courses. But right here, the domain is all the x values. Well, it's going to go forever this way and forever that way. And so it's going to go forever left and forever right. And so that is all real numbers. It's going to hit everything to the left and everything to the right. All real numbers. Every number is a domain. The range is a little different, because the range is all the y's. Well, it's not going to be any y's down here, but you see all the y values is going to go up forever from here. So that's going to be y is greater than or equal to negative 2 right here. Got it. Okay, so now I did the first one. Guess what? You know what's going to happen. You do the second one. Ready, set, pause, go. All right, let's see what we got. I'm going to write the answers down. X equals negative 2 for the axis of symmetry. Negative 2 is your vertex. we have two zeros, which are -1 and 0, and -3 and 0. The domain is x equals all real numbers, so it goes from the left and the right forever, and the range does not go up and down forever, but it starts at -2 and goes up forever, like that. Okay, any questions, raise your hand with that one. Last one I'm going to do. Here we go. Now we're going to put it all together, boom, right here. See that? From that, I'm going to graph it, and I'm going to answer all of these questions. Wow, okay. I think we can do it, though. First thing, identify the zeros or roots. Okay, so that would mean I need to find the zeros. So I need to factor, okay, let's factor over here. So -2 on the top, -3 on the bottom. What adds to -2 and multiplies to -3? That would be -3 and 1, right? So I'm going to rewrite this over here. So it's going to be y equals x minus 3, x plus 1. Okay? Ooh, so we put it 0 because I want y equals 0. Where does it touch this axis of y equals 0? So it's going to be x minus 3, x plus 1, and my roots are 3, 0, and -1, 0. So I got the first one, 3, 0, and -1, 0. We did this before, now we're just going to put it all together. Does it have a minimum or a maximum? Well, in order to figure that out, I look at A. You see A is 1, A is positive, so it's going to open up. We learned in the shift lesson that if A was negative, it opened down. So this one's going to have a minimum. Okay, next, axis symmetry. Ooh, I remember that. That would be x equals -b over 2a. Oh, before we do that, let's plot our points as we go, shall we? So I got 3, 0, 1, 2, 3, and -1, 0. Boom. Let's put that. So we got our two zeros. Now we can get our axis symmetry and our vertex, and we in biz, okay? So, where are we at? So -b. What is b here? Oh, -2. Should be able to just look at it and know. So it's -2. Okay? -1 times -2. Over 2 times a. What's a, boys and girls? Oh yeah, that's 1. Got it. So that's going to be -1 times -2 is 2. And 2 times 1 is 2, which is 1. Okay. So 1, dot, 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 dot. There's my axis of symmetry. That cuts it in half. Okay. So, what else? We have to do, we have to do the vertex. So axis of symmetry is x equals 1. We got that. So vertex, so now I'm going to plug in. Okay. So y equals, so I'm plugging into this thing right here. So, plugging in the 1. So that's going to be 1 squared minus 2 times 1 minus 3. So that's 1 minus 2 minus 3. Ooh, 1 minus 2 is -1. Minus 3 is -4. Woo! So it's 1, -4. Okay, 1, 1, 2, 3, 4. Boom, right there. So I got that. Y-intercept. Ooh, y-intercept. So that's actually just this. So when you put, so you got y equals x squared minus 2x minus 3. If you put in 0 for x, you get -3 for y. Right there. So it's 1, 2, 3. Boom. And I have actually 1, 2, 3, 4 points, so I can draw my parabola like that. Domain, x equals all real numbers. What's the range? Yeah, you got it. Y is greater than or equal to -4. Graph at least 5 points. We have 4 right now, so I think that's good enough. Because we only need 3 to graph a parabola. Okay? Boom, right here. Ooh, you got 2 of these all on your own. See if you can knock them out. Ooh, this one has a -1 for a. That's going to be interesting. Check it out. Ready, set, go.